Good afternoon. As I promised you guys to put a video for all of you about the continuing the sessions that we should have a very good time for it on that was on Thursday last week. So basically I'm going to make more than one video. I will try to make it shorter videos so you can take a look of them one by one. So the topic, guys, if I'm just going back to the situation I have here, I would like to share with you guys the whiteboard, Microsoft whiteboard, and that is a very important thing because it's better than the Blackboard Collaborate itself. So I am going to share that with you now, if you can see my screen, hopefully. So today's topic actually is about real numbers. And as we started a little bit in this chapter, which is chapter number 7, we try to finish this chapter and chapter number 8, hopefully by this weekend, the next weekend, and see what's happening. So the topic here, guys, is actually real numbers and operation on them and operation on them. So I think we started a little bit two tables. I'm gonna try to review these two tables. We had it before. These two tables, guys, are very important. The first table was about multiplication and division table, and I'm going to review that with you because it is important. Then we may go back to the book because in the book we have some other important things to discuss, especially the topic of absolute value. But I believe that we need to review this before we go to the absolute value and before we go to the first or second exercise. We had the previous exercise about the real numbers and how we are going to classify the numbers when we took part of chapter 7. That was the beginning. I think you guys know about it. So basically, I gave you the last exercise was in page 492, and I asked you to do some of the questions under the synthesis from 69 to 72. Anyway, let's go down, and then some people would like to, let's make this one more public for the people would like to see this video. So starting from the operations and reviewing the table of multiplication and table of division, which is I'm going to do it now one more time. So we said that multiplication and division table. So we say that multiplication and division table. So the first one here, guys, I'm going to take this table here as we did that. We said that number one, if I multiply a plus times a plus, the answer is always going to be plus. Number two, if I multiply minus times a plus, the answer is going to be minus. And number three, if I multiply plus times minus, the answer is going to be minus also. Number four, if I multiply minus times minus, the answer is plus always. And I named the last one. I used to say that that's a smiley face, which is people like it, according to this one here. So the division table, guys, this is multiplication table. Well, we have division table. So the first one here, if I divide a positive number by a positive number, so that's going to be, let me just make this nicer maybe. If I multiply positive by positive, the answer is going to be positive. And if I, number two, if I divide negative by positive, the answer is going to be negative, like the same 0.2 in the multiplication table. Number three, if I divide, a positive by a negative, the answer is also going to be negative. And the last one, which is we said previously, like a multiplication table, if I divide minus by minus, I divide minus by minus, and that's going to give me a positive. The answer is going to be positive. So this is multiplication table and division table. So we said that minus by minus is smiley face. Okay, and now we take some of the examples, guys, before we go to the addition and subtraction table. Like if I have, I'm just going to show you plus 3, and I multiply that by minus 5. Look at the, or my multiplied by plus 5. Let's do it this way. So the answer is going to be plus 15. You see that? And if I have another example, which is minus 3 times plus 5, and this is multiplication, so the answer is going to be minus 15. And if I have a plus 3 times minus 5, the answer is going to be minus 15 also. But when I have a minus 3 times minus 5, the answer is going to be plus 15. So that's a clear thing. We'll take two more examples, two more numbers as an example for the division table. Then we go to the addition and subtraction table, and after that we go to the book and see what can we do for the next things. And I can give you something like a worksheet from one of the worksheets, which is important worksheet. They would like you to have it. So let's divide like two different other numbers. Let's divide plus 6 by plus 2, for example. The answer is going to be plus 3. And that's number 1. And number 2, well, I can give some numbers here. If you would like me to do that, maybe we can organize it in a better way. So this is number 1, number 2. How about if I have a minus 6 over plus 2? The answer is going to be minus 3. And number 3, if I have a plus 6 over minus 2, the answer is going to be minus 3 also. And number 4, how about if I have a minus 6 over minus 2? The answer is going to be plus 3. So from this, you can see that the situation of the multiplication and division is going to be the same. Now we can go down a little bit for the addition and subtraction table, and I'm going to review that also. Addition and subtraction table. Subtraction table. And I have here 3 important topics, which is I would like to make it like this way because people would like to see the answers in a organized way. So the first one, if I add, I'm going to take an example now here. If I'm saying that 3 plus 3 plus 5, so both of them are plus, I will put the plus outside and I add them inside. So that's going to be, as you know, this is very easy one. It's going to give me plus 8. Now, number 2, if both of the numbers are negative and there's no multiplication or division between them. Like what? Like if I can write down negative 3 and negative 5. So there is no multiplication. This negative, guys, is important to know that this negative, if I change the color here and make it, this negative is belong to this number. And the other negative is belong to the other number. So this negative is belong to this number. So basically, we are subtracting twice. We are subtracting 3, then we are going to subtract 5. So the idea is sign, because both of them having the same sign, which is minus. So we put minus outside, and we are going to add again these 2 numbers inside. So we are going to have a minus, and there's an 8 inside the bracket. So the answer is going to be minus 8. Does that make any difference if I take the same example, but minus 5 in the beginning and minus 3 at the end? It doesn't make any difference, but I just show you that the answer is going to be the same. So we are going to have minus 8. Very important, guys, to have this relation. Now, the third one, which is the most important one, maybe it's all of them are important actually, but I just want to say that this is 2 dash. Let's make it 2 dash. And this is also 2 double dash. So just an example because it's a 2 dash and 2 double dash. Let's take number 3. Now, how about if we have one of them plus and the other one is minus? In this situation, we can have 2 different situations. One of them, if the 3 is plus and minus 5, and the other one, if the 3 is minus and there is a plus 5. So how do we describe this situation? We guys, let me show you something very important. I'm going to make a statement for you, and then you are going to have this statement always when you are adding and subtracting 2 numbers carrying 2 different signs. So the first thing I'm going to write down here, guys, I will say that sign of the bigger number, sign of the bigger number. So I'm just going to put this inside the bracket, a bigger number, sign of the bigger number. So I close this and I close this. And then I multiply this by, and I will say here bigger, and I put a minus in here with a different color, smaller, and I will say regardless their original sign, regardless their original sign. Do you see that, guys? So let's take an example for both of them. So the first one, the sign of the bigger number is minus because the bigger number is 5. So I'm going to take the sign of the bigger number, which is minus. Put minus, then I put a bracket. Then bigger number, regardless, now we forget their original sign. We just put the bigger number without sign, which is 5, and we put minus. Smaller number without its sign, which is 3. And let me just make it this way. And then I close the bracket. So the answer is here equals. So now I have a minus, and then 3 take away from 5. That's going to give me 2. So the answer is going to be minus 2. The answer here is minus 2. The other situation, which is the bottom situation, now you can see that the sign of the bigger number is plus. So the bigger number has a sign of plus. So I'm going to put a plus here. And I open the bracket again, bigger number, and I put minus because that's a part of the original of the statement. And then I put a minus, and then I put the smaller number. So now the answer is going to be plus. That's going to be the answer is plus 2. So there's a difference in the answer. So the most important statement is this statement, guys. I would like to share this statement with all of you. That's a very important thing. So I want you to have this. And let me organize it a little bit so we can make it this way so nobody can forget that ever. And basically, if I want to put the color, it's very important to have this, guys, in your mind so you don't forget that the situation is about the sign of the bigger number, and then always inside the bracket, take away the original sign they have and subtract the bigger number subtract the smaller number from the bigger number. And I am going to just show you this. So basically, this is the idea that we need to have it when we are going to add or subtract numbers. Well, guys, this idea is going to be right also, even if you have a fractions. So it doesn't matter if you have a fraction or if you have a whole numbers carrying minus or plus sign. This is the idea, guys, and I want you to practice this. Very important. Now, let's go down and then we go to the orders, guys. Let me just take the orders. We have now, for the people I'm teaching, the page is going to be, the page of the textbook is 499. And we take the orders, so 499. Page 499. It doesn't matter. The topic is the order. The topic is the order. And so that's the situation. I'm just going to show you guys some important things about how you take the orders for the positive and negative numbers. So it's important when you compare positive and negative numbers. It's very important. But the situation is the statement I have actually, if I can make I will make a statement from the book. You always try to have it. And if I can save that somewhere and put it here for you, so make a screen shot for that. And then, so I will just try to see if I can give it to you guys as a documentation. That's very important one. And let me double check that so I can put it for you here. I want to put it in here so people can see that easily. What's the statement saying? I want to show you exactly the statement because that statement is actually open a lot of important things from the idea that how do we understand the numbers. So let me copy that, and if I can put it on here, like let me see if the paste is allowing me to do that, or I have to bring the image from yeah, just make it smaller. This is look like a very big one, so and I will move it in here, then I will keep it, and then I move everything else. So basically let me just make this bigger, and then I bring the paper in the middle. So now I will make it 100%. Let's just make it smaller a little bit. So yeah, maybe 101 is not bad. Okay, so that's a statement, guys. Here we go. Because the other one, we had it here. This is the statement, maybe a little bit bigger. And if I just make it smaller, I can make it smaller. So here, do you see that, guy? If A is smaller than B, it can be written also B that bigger than A. So basically, guys, we take examples. When we take this, we take examples about numbers we have. And I will show you guys here. So the first example is, let's say that I'm comparing 3 as a positive number, and I will say that 3 is smaller than 5. And that's right. But this means that it is equivalent to, if I make 5 is greater than 3. That's the same statement. So that's the same thing. How about if I'm comparing one number with positive, one number with negative? That's clearly, people understand that. If I say that negative 3 is actually smaller than positive 5, that's right. It's perfectly right. Negative 3 is smaller than positive 5, which means 5 is greater than negative 3. That's a statement which can be written in a different way. But how about if I have two numbers, both of them are negative? So let's say that negative 3 and negative 5. We need to put the sign here. Well, guys, if I put these two numbers on the sign, number sign in here, number sign in here, that's what we know. And the number sign, guys, it's 0 in the middle. Well, positive numbers, all of them are here, which is, we know that, starting from 1 and 2 and 3 and then 4. And the negative numbers on the other side, negative 1, negative 2, negative 3, and then negative 4 and negative 5. So I'm just going to stop at negative 5 because that's what we needed. When you see, guys, you can see that the distance between negative 3 to 0 is 3 units. And we can see that clearly. But the distance between negative 5 and 0 is actually 5 units. So negative 5 is far away from 0, which means, in another word, if I can take an example representing this in money-wise, it is more debt. So what's better to have, negative $3 in your bank account or a negative $5? Of course, people think that negative 3 is better because it's less debt. So basically, negative 3 is now, in this situation, is greater. It's greater than negative 5 because it's closer to 0. Because it's closer to 0. This means that this is equivalent. If I put negative 5 in this side, I will say that negative 5 is smaller than negative 3. So this is the topic of the order I would like to share with you from the textbook. So according to this, we understand a lot of things. Well, guys, we can take this even by using some of the variables, and I'm going to show you in the same time the page that I would take it from the book, which is I told you about it. If I just go back and take some of the variables, more examples. If I take more examples in here, so if I say that, just an example from if I can take it from the book, or take it from myself, it doesn't matter. Now, if I say that x is greater than, if I say x is greater than 4, doesn't that mean that this is also equivalent that 4 is smaller than x? This is the same statement. Or if I can say that in a different statement here, I can say that y is greater than negative 2. Doesn't mean that -2 is smaller than y. Now, these are examples with the greater. How about if I have x, the same thing, but it is smaller than 4? Doesn't that mean as well that 4 is greater than x? Of course, yes. And if I say that y is smaller than -2, y is smaller than -2, doesn't that mean that -2 is greater than y? Of course, yes. So that's actually the things I would like to show you in here. If I want to show you some of the examples from the book, I'm just going to try to share my screen one more time. Maybe I can share it with the textbook. If I have it in here, I will share that. Or share, guys. I think this is some of the examples about the orders. Page 499, as I told you. Hopefully you can see it soon. Is that possible to see it now? If I share my screen here, I don't know if you can see that now. Can you see that? Yeah, here maybe, guys. This is the situation of having, and you can see, guys, this is negative. Question number 20 and 21 in page 499. It's clearly shown in the textbook we are talking about. Well, that's a page 499. Well, guys, we can go down a little bit, and then you can see some of the examples in here, which is question number 22, 23, 24 in page 500, 500. We are in page 500, actually. And by the way, guys, there's also some of the questions. Well, when you see this sign, smaller and equal, or this sign, I'm just going to make it like this. This means that smaller and equal, and this sign means greater and equal, greater or equal, actually. It's not and, it's or. It is smaller or equal, greater or equal, and this sign is also the same. So, guys, now we are going to, I'm just going to show you the other thing here. For example, guys, these examples 25, 26, 27 in this page, which is page 500, it does show that -3 is smaller than 5.4. True, when -3 is smaller than -5.3. And it is true when -3 is equal to -3. Yes, that's right. Yeah, that's also true. Question number 27 saying that -5 is greater than 1 2/3. This is a false statement because -5 is not greater than any positive things, because that's a true. The first two statements are right. The last statement is a false statement. So it is false, since neither -5 is not greater than 1 2/3, nor -5 is equal to. So that's a false statement. You can see that. They are going to ask you here, write true or false on this statement, which is a good idea. But in the previous one, we didn't have write another inequality, just writing inequality in a different way. Well, guys, the orders, we named that inequality because we have that starting from after I explained for you about the type of the numbers we have. So that's the order. And I'm going to say, guys, here, now let's go to the absolute value definitions. So it is very important to see the absolute value definition, and you can see that, guys. I mean, it's clearly in here. So I'm going to read it. It's the absolute value of a number is the distance from the zero on the number line. We use the symbol two parallel lines, vertically parallel lines, and x between them to represent the absolute value of the number x. And you can see, guys, this example is very important. Let me just make the screen bigger so people maybe can see that easily. And let's go to this place here. So that's the definition. And it says that the distance of 4 from 0 is 4 units. The absolute value of the 4 is 4. And the distance of -4 from 0 is also 4 units. So the absolute value of the -4 is 4. So basically, guys, the absolute value is something that I want to say that it is representing the distance from 0. The distance from 0. Very important. This is very important topic. Let's go down and see what we have here. Finding the absolute value. Writing this statement is important because it says that if the number is negative, its absolute value will be opposite. Its opposite is if the number is 0 or positive, so the absolute value is going to be the same number as it is. And we can see that some of the numbers here is in examples. We have in 28, 29, 30, 31, 32. And there's also questions I would like you guys to take a look of it and do it. Find the absolute value of all of these numbers. So that's an easy way of doing that. Basically, guys, after that, we have the exercise 7.2. 7.2, guys, is the exercise showing us some of the important questions from this book. And I would like to choose some of the questions, not all of them maybe. I state the integers that correspond to the situations. I think I'm going to select starting from part B, maybe. Like saying that graph the number on the number line will means put that number on the number line. Guys, for the positive numbers, just divide that 10 by 3. That's going to give you 3.33333, and then put it between 3 and 4 in here, this place here approximately. For the negative, guys, first make the division. So take a look of what's the meaning of the division of 17 over 4 first, and then attach that to the minus. So you know where 17 divided by 4 exactly. Well, guys, 16 divided by 4 gives me actually 4. So 17 divided by 4 without the sign is going to be a little bit more than 4, which is approximately 4 and 1/4. So 4 and 1/4, but in minus. So this is negative 4 in here. So you are watching this place approximately in here. So that's the situation. And then same thing with the other numbers. For the numbers like question number 13, you are going to get rid of the mixed numeral, make it improper fraction and divide it and see what's happening. Or you just say that it is 5 and 2/5, but 4 and 2/5, but it's minus. These are some of the questions. I would like you guys to solve all of these problems, not just the odd numbers of them. The word problem in the beginning, in part A, I don't think that there is a question which is very important there. We can go to part C. In part C, page 503, you can take only the odd numbers of the questions. And part D also, you put the sign bigger or smaller in here. And we continue to the page 504, and there is a questions about absolute value. Skill maintenance is not something very important. We had that in chapter 4. Synthesis, I don't think any important questions in the synthesis neither. So I think addition of real numbers, I gave you the rules of the addition of the real numbers. So there's some of the examples in page 505, which is these examples. Look at these examples. We can apply the third statement I gave it to you previously. These are just example about adding, and I would like to go over these questions. And adding without number line, which is this is the rules. I gave you the rules of the 2 positive and 2 negative and positive and negative. So you have it here also, but you can practice that. And the same situation here. So the way of taking the absolute value, I didn't like it very much. So I prefer you guys go to the 3 statements I gave it to you in this situation. And these are numbers, guys. Page 507 is very important. So I want you to solve all of the questions in this gray rectangle, which is 7, all the way to question number 20. All the way to question number 20. Now, guys, one important thing before, like I know that some of these questions, maybe we need to do it together. So some of them has a bracket in it. Whenever you see a bracket, means that the sign outside of the bracket is going to be multiplied by the sign inside the bracket. So if I take, for example, some of the questions like 7 and 8 and 13, 14, and 19 and 20. Let me try to solve some of these questions on the whiteboard. and then you will see the answer. Well, of course, the other things is very important. Also, page, the same page, which is 505, 507, questions number 21, 22, 23, 24. And now these are the same rules, well, which is I'm going to opposite or additive inverse. We are going to take this later on, but let me select some of the examples here, and then we can apply that. So if I share my screen one more time as a whiteboard Microsoft, so I'm gonna go and share my whiteboard Microsoft again with you guys. Hopefully you can see the screen soon. And I'm going to solve that and take some of the examples. Hopefully by the next video, you will see, in the next video, guys, you will see more examples about the rest of the topics of this chapter. Let me share the, I don't know if you can see my screen now. Yeah, good. So I'm gonna make that line. Let me just start with some of the questions we had in page 507. So if I go a little bit up, so I have a page 507. Page 507. And there's the questions. For example, question number 8. It says here, guys, in question number 8, -5 plus minus. So -5 plus and then -6. Look at what's happening. As we said, guys, the bracket itself is representing multiplication. So the bracket is multiplication. This bracket, guys, means multiplication. So basically, we are multiplying plus times minus, and plus times minus means minus. So I'm going to rewrite it as a -5 -6. Then I can apply the second rules. I put it for you already. So we put minus and we add them together. So that's going to give me a -11. And question number 9, for example, just another question. It says -9 plus -3. So -9 plus -3. Again, the bracket is multiplication, and you are going to multiply positive by negative, and that's going to give me a negative also. So that's going to give me a negative. So this is going to be -9 -3. Total is going to be minus, and we add 9 plus 3. So the answer is going to be -12. That's the second question. Now, maybe people like also to solve some of the problems using decimals. Is the same thing, guys. I can give you 1 decimals and 2 fractions. So question number 17 is decimal with a bracket, of course. That's why I would like to share it with you. So -4.5 plus -3.2. So question number 17, -4.5 plus and then minus 3.2. Again, guys, the multiplication means, the bracket means multiplication. We are multiplying plus times minus, which means the answer is going to be minus. So you are going to have a 4 minus 4.5 minus 3.2. So basically you are adding them, having the same minus. So 4.5 plus 3.2, that's going to give me minus 7.7. 7.7. Do you see that, guys? This is a type of decimals. And the other one is going to be, I believe it's question number 18, sorry, 19 and 20. Let's do 19 and 20. And then if we have time, so we can take more examples, or maybe we can do that in the next video. So question number 19, sorry, again, it's question number 19 in here. So I'm going to have this question, and I will write down the question for you. It is 5/9 plus minus 7/9. So that's easy one, 5/9, and there is a plus, and then it's minus 7/9. Well, guys, again, as I told you, that the bracket represents multiplication. So we're multiplying plus times minus from outside of the bracket and inside of the bracket. That's going to give me 5/9 minus 7/9. And now you have the same denominator, which is 9, and then the top is 5 minus 7. Again, guys, 5 minus 7 is, as we said, that the sign of the bigger number. Well, if you don't see a sign, means it's positive. If you don't see any sign, means it's a positive. So sign of the bigger number is minus, and you take away the smaller number from the bigger number, or bigger minus smaller, and that's going to be divided by 9. So the answer is going to be negative 2 divided by 9. Or in another word, without the bracket, negative 2 over 9. And you can put the negative with the top part or with the bottom part or in the middle. So that's going to be easy. Wait, question number 20, guys. Maybe we can take this question because the denominator is different. So it says that minus 1/5 and then plus bracket minus 3/4. So guys, this question is also important, and I would like to solve this type of questions for you so people can see the idea. And now, again, the bracket going to represent a multiplication, plus times minus. We are going to have that. So it is minus 1 over 5 minus 3 over 4. Again, guys, as we studied that previously, we have a different denominator. So we need to have a common denominator, which means that we need least common multiple. And according to this, least common multiple between 5 and 4 is actually 20. So we need to multiply the bottom here by 5 and the top by 5 also, and the top by 4, bottom by 4, and we rewrite that. Don't forget the sign. So this is going to be minus 4 times 1 is going to be 4 over 4 times 5 is 20. We have a minus 3 times 5 is 15, and then 4 times 5 is 20. Now we have two numbers. We multiply, actually, we have with the same denominator. So they have the same denominator. Okay, so we keep the denominator as it is, and we write down the two numbers on the top. So it's minus 4 minus 15, which is both of them are minus. So we add them with minus. So that's going to be 4 plus 15, as we did that previously, and that's divided by 20. So the answer after all of these steps is going to be minus 19 over 20. And that's actually the final answer for this question. I think, guys, according to these good examples, there is a lot of beautiful examples. Let me just share my screen one more time with you. So basically, you can see this again, having, if you can, I don't know if you can see the screen now, trying to share the textbook, which is sometimes it takes a little bit of time. Well, let's share that with the textbook, which is, I'm going to put it in here. Trying to see that. Now I think that you can see it. So let's go back to the textbook, guys. So make this video a little bit shorter. Then I will have another two videos. Look like when I add the maybe my screen is showing all of these. That's good. Okay, guys. So now these questions were already, I told you guys to try to do these questions in page 505, starting from 7 to 20, all of them. And the other one is 21 to 24. That's beautiful questions also. And now here there's a statement saying that opposite or additive inverse. So two numbers whose sum is 0 called opposite or additive inverse of each other. This is very important statement, guys. I would like you to pay attention to it. One more time, let's read it. Two numbers whose sum is 0 are called opposite or additive inverse of each other. And this is the examples about that. It says that find the opposite additive or additive number, additive inverse of each of the numbers. So basically for 25, the additive inverse is positive 4, 26 is negative 8.7, 27 is positive 7.74, 28 is positive 8 over 9, 0, 0, 30 is negative 12. So these are the numbers we try to. And then you can see, guys, the answers at the end of the page as I showed you previously. So now you know that. So basically, guys, this is important. I'm just going to go over last page before I finish this video. Find the opposite or additive inverse of each of these numbers. You can see these things here. And now symbolizing opposite, guys, this is also important to remember. I think the second one is more important, the opposite of an opposite. Symbolizing opposites, the opposite or additive inverse of a number a can be written or can be named as minus a. Read the opposite of a or the additive inverse of a. The second statement saying that the opposite of an opposite. So this means that the opposite of number is the number itself. Why? If you take a look, guys, of the two minus, one of them outside of the bracket and one of them inside of the bracket. And we say that the bracket is already representing multiplication. So you are multiplying minus times minus. And minus times minus is positive. It's a smiley face. I'm going to show you one more time. That here is just showing you some of the examples about evaluating minus x and minus x when x equal to 16. So when you have just x equal to 16, you substitute 16 inside and minus 16. Minus times minus is plus. That's going to give me positive 16. There's also examples here, a lot of good examples on this page, starting from question number 31 all the way of question number 36. But the beautiful one here, as I see in example number 19, it says that if x equal to minus 3, then minus x is minus 3. That's nice. And they said that if x equal to minus 3, then minus x. That's beautiful. So you have two minus, one from outside of the bracket, one inside of the bracket, but x itself is another minus. So basically the first two minus going to make a plus, and then that's going to be minus. I would like to share this with you guys. Maybe I can give you these examples before we finish this page and stop at page 508. So let me just go back to the Microsoft Whiteboard, which is the beautiful one here. I think that you can see, hopefully you can see my screen now. Just waiting to make the screen shows on the on my here. I think you can see that. Now I'm going to show you guys some of the examples here, and I will see how this is going to be important for everybody. These examples are like just taking some of the examples from the previous page I was talking about, and that page was page 508 and page 508. So I'm going to go here, page 508, and they said that minus a, as again multiplication, the bracket is multiplication, and this is a smiley face. So it means that I have minus times minus, which means plus a. That's the statement we had it. And now we're going to apply that in some of the questions. Like this question saying that what is if x equals to minus 3, for example, what is minus x? Well, you can write down minus, and x itself, I will put it inside the bracket, which is minus 3. That's a smiley face, which is going to make a plus 3 the answer. But the other one saying that if your x is minus 3, what is minus x? Well, that's going to be a little bit more funny because already this is a smiley face, which is positive, but they made it in the book in this way. It said minus, another minus, but then the x itself is minus 3. So there's a 3 minus here. So let's make it nicer here. So I'm going to go from inside. This is a smiley face, which means that I have a minus very outside. That's going to be plus 3. Then I will multiply the minus from outside by the plus inside, and that's not a smiley face, that's a minus. The answer is going to be minus 3 in here. So these are some of the examples, guys, very important to know. And I believe I may make another video later on to continue more pages under this chapter. But one of the things that they asked me to find out, which is I may make it a shorter video, it's about least common multiple later on. So thank you so much for this, and then I will post another maybe 2 more videos continuing this chapter, more topics in this chapter. Thank you so much for listening to me.